Hey class, in that last example we were given angle, a side, and an angle, that sequence. In the previous example before that we were given a side and then an angle to follow. Here we're looking at a different situation where we're going to be given two sides followed by an angle. And this is a little bit ambiguous because there's more than one particular outcome that we can expect. So one such case would be if there's no triangle, because the presumed side falls too short. And then some other cases here, we've got exactly one right triangle. We have a possibility of two outcomes where this particular side either drops down and creates a shorter side here, or it drops down and creates a longer side here. Okay, and then we could also have one triangle where there's two acute angles and one obtuse here. And let's get started with these. Okay, in this situation, let's sketch up a triangle. And we won't worry about the side lengths or anything. We'll just set it up and label the condition. So if we called this angle A, then the side length opposite the angle is little a. And then so we can say this is B and this is C. And C is 50 degrees, so I'll just go ahead and replace that with 50. And then opposite C is a 1. Okay, so this is the scenario, and we're going to find out whether or not this is going to work. So if I ask for the sine of 50 over opposite side 1, it should be equivalent to the sine of A over its opposite side 2. Okay, so A equals 2. All right, so what are we missing here? We can only have one unknown if we wish to solve an equation. What we don't know is the sine of A, but we can go ahead and if we cross multiply this, we get 1 times the sine of A. 1 times the sine of A is equal to 2 times the sine 50 degrees. Okay, so if we put the right side into our calculator, we take 2 times the sine of 50 degrees. And we get 1.532. I'll just round it to 2 places. Okay, so we would ask for the inverse sine of 1.53 to find A, and there's no such thing, right? Remember that the sine, it stays between 0 and 1. Okay, so this is an impossible situation, and what they've really set up here is something that would look like this: 50 degrees here, and then opposite that we have 1, and then we have a 2 here, and angle A somewhere over here, but we can't reach it, so there's no solution here. Okay, let's look at another situation. So I'm just going to try and draw this to the best of my ability with the knowledge that we're given here. And a 40-degree angle is just a little less than a 45-degree angle, so I'm thinking something like that. And this is our angle A, 40 degrees. And then opposite that, we have a length of 3. And notice that if this is going to be B over here, and this is B, B is the angle here. Now I need for the length 3 to be longer than B, which is 2. So that's going to put it over here, something like this. And so actually I want to be here. And that leaves us with C. And its unknown length on the opposite side, little c. Okay, so let's set this up. The sine of 40 degrees over its opposite side, 3, a equals 3, should be equivalent to the sine of B over its opposite side, 2. Okay, again, if we cross multiplied, we get 3 times the sine of B is equal to 2 times the sine of 40. And now we divide both sides by 3. So the sine of B is equal to 2/3 times the sine of 40 degrees. Okay, so we can actually put this directly into the calculator. So the inverse sine of 2/3 the sine of 40 degrees. All right, so let's find this. I'm going to take the inverse sine, so second sine, and then in here I need 2 times the sine of 40 degrees. I'm going to divide that by 3 for my 2/3 sine 40 degrees. Tells me that my angle is 25.37. Okay, there's also another situation though, because remember that the sum of the angles in a triangle are 180 degrees, and if we look at where we'll have a sine, which is the y-coordinate, it's positive both places within 180 degrees at 25.37, and then at that same location that's 25.37 degrees above the 180. So if we took 180 minus 25.37, we find another place that has the sine that we're looking for, and that turns out to be about 154.6 degrees. All right, and we can see right away that if I wanted to use that as my angle and then I add the 40 degrees here, we're already above the possible outcome. So that's not a possible angle in our scenario, so we're going to keep this one. So B is 25.37 degrees. And now we've only left to find C, and big C and little c. Okay, so let's quick calculate the angle in the interior here, which has to be, since 40 plus 25.37 plus C add up to 180, I can calculate and find C is equal to the total sum of the interior angles minus the known angles, 40 and minus 25.37. So we've got a measure for C about 114.63. All right, that allows us now to set up another law of sines, and we'll use the fact that the sine of 40 degrees of its opposite side 3 is equal to the sine of what we found for C, 114.63, of the unknown side length of C. So we will both cross multiply and divide both sides by sine of 40 degrees. So C times sine of 40 degrees equal to 3 times the sine of 114.63 degrees. And then, of course, we want C, so we'll divide both sides by the sine of 40. Okay, and if we put that into our calculator, we should get a value for the side length of C to be about equal to 4.24. Okay, so the C part is 4.24. And we've solved our triangle.